Hey everyone, so let's talk about building RAG systems. It can get kind of messy, right? Well, today we're looking at a tool that wants to change all that. It's called RAGDiff, and it's all about turning that gut feeling into cold, hard data.
You know the feeling, right? You've just spent a ton of time improving your RAG system. Maybe you swapped out the embedding model or tweaked your chunking, and it just feels better. The answers seem sharper. But how do you actually prove it's better? How do you put a number on it?
And that's exactly what this is all about. We're moving away from that subjective feeling that I think this is better to something objective. Something like, this version is precisely 5.5 points better on quality, and here's the proof. So yeah, let's dive in and see how it actually works.
Okay, so before we get into the solution, RAGDiff, let's just quickly frame the problem it's designed to tackle.
So, RAG evaluation, it's basically the process of, kicking the tires on your system. But here's the thing, without a solid framework, it's just chaos. You run a few queries on the old setup, a few on the new one, but are they even the same queries? Was everything else identical? It's really easy for things to become totally unreproducible.
And this is where RAGDiff steps in. It's designed to bring a structured and, most importantly, reproducible workflow to cut right through all that mess. Let's break down how it does it.
Honestly, the best way to get your head around RAGDiff is to think of it like A/B testing, but built from the ground up just for RAG systems. You can take two different configurations, put them in a ring, and let them fight it out in a totally controlled environment to see which one is the real champion.
Okay, so here's how it's all put together. The whole architecture is really clever. It starts with a domain. Think of this as your project workspace, like medical research or legal docs. Inside that, you define your different systems. These are the actual RAG configurations you want to test. Then, you have a query set, which is just a consistent list of questions you'll hit both systems with. When you run that test, it's called a run. And the final piece of the puzzle is the comparison, where you use an LLM as a totally impartial judge to score the results from your different runs. It's a really clean, logical process from start to finish.
And here's the absolute killer feature. This whole structure makes your work truly reproducible. Every single time you do a run, RAGDiff basically takes a snapshot of everything. Your exact system config, the query set, all of it. So you could come back 6 months later, run the same test, and get the exact same results. That's a game changer. No more guesswork.
All right, so that's the theory, which sounds great, but what does it actually look like when you use it? Let's check out the squad demo that ships with RAGDiff. It's a perfect example, pitting two very different systems against each other.
So in one corner, you've got Face Small. It's the lightweight contender. It's fast, built for high throughput. And in the other corner, Face Large. This one's the heavyweight. It's bigger, a bit slower, but it promises much better semantic understanding. I mean, this is the classic dilemma, right? Speed versus accuracy. Which one do you choose?
So, who takes the crown? Well, instead of just winging it, RAGDiff gives us what we came for, a data-driven verdict. Let's see what the numbers say.
Okay, first up, let's look at the average quality scores out of 100. And the larger model, FI's large, does come out on top. It scores a 67.0 compared to 61.5 for the small one. So it's a win for sure, but maybe not the knockout punch we were expecting.
But this is where it gets really interesting. If you look at the win-loss record, FI's large is the clear winner. It won 24% of the matchups versus only 7% for the small one. But then, look at the latency. FI small comes in at just over 32 milliseconds. That is way faster than the 56 milliseconds for the large one. So now you have a real quantifiable trade-off. Is that higher win rate worth the hit on speed? That's a decision you can now make with actual data, not just a hunch.
But wait, there's more. RAGDiff doesn't just stop at the what. It helps you understand the why. So we know FASI large won, but why? What does better semantic understanding actually look like on the ground?
Check this out. Here's a query. What alumni wrote The Closing of the American Mind? The large model just nails it, points directly to Alan Bloom. The small model? It completely whiffs, gives back totally irrelevant info and gets a big fat 0. This right here, this is a perfect, concrete example of what better actually means.
And it's not a fluke. Here's another one. The question is about a symbol used in the 20th century. Again, FI's large gets it right, the show globe from pharmacies. And again, the small model is just lost, returning junk, gets another 0. See? This is the kind of insight you can actually use to understand what's going on under the hood.
So, when you put it all together, what's the big picture here? It's all about moving towards a more systematic, more principled way of developing RAG systems.
And that's because the tool itself is built on some really solid design principles. Work is organized by domain. Every run is reproducible. It's designed to fail fast, so you're not guessing about errors. It uses type safety and has a ton of tests. The point is, this isn't some quick and dirty script. It's a proper, systematic framework for building better RAG.
And really, that brings us to the final question we should all be asking about our own work. Is your RAG development based on guesswork, on a gut feeling, or is it based on solid, reproducible data? Something to think about. Thanks for watching.